Hi, this is Margo. This is Sunday, early evening, August 20th, 2023. I hope everyone is safe and doing as well as possible. And another week has passed, and I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube, where we go over methane, sea ice, climate-related items, and we're also going to be looking at the Hilary storm and show you how I tracked that and a couple of other things. So I'm going to start out, first of all, addressing a comment that came in under last week's show. Remember, someone had emailed me the secret link for the Arctic sea ice thickness at the Bremen University website, and so I've been showing that for a couple of weeks, and then I got a comment from Dr. Lars Bergman, 9725, and he says, "Hello Margo, thank you for your great work, really appreciated. Regarding the sea ice thickness chart from University of Bremen, as far as I know, these charts are not valid for summer months with meltwater, as this meltwater corrupts satellite data." And I had seen that on their website. It wasn't really worded that way. I had seen it, but since Sam Carana has been using the model to show sea ice thickness, I thought it must be valid. But anyway, I respond and I say, "Thanks for your comment, Dr. Bergman. I saw that on their website about these readings only being valid during winter. Has anyone told Sam Carana about this? He uses this chart for summer Arctic sea ice thickness. Also, the page with this data is buried on their website. A viewer sent me the link, otherwise I would have never found it. Thanks for watching." So that was my response. And to follow up on that, I want to show, this is University of Bremen website, and this is the page, and the model is called thin ice thickness. It's the thin ice thickness model, so that's confusing right off the bat. And here, it's a new data set that they started on October the 8th of 2022, so not quite a year ago. And it says, we released a new data set, version 300 of the SMOS/SMAP thin sea ice thickness data in our data browser. SMAP data is currently not available since August 6th of 2022, so that our NRT product only includes SMOS data. And then it shows the changes that they did in the update. And then they had another update here, November 8th, that the SMAP data is available from October 5th, 2022 again, and included in our version 300 product. And then they show the Antarctic for August 19th, and this is I guess detailing the thin ice, and I still don't know exactly how to read all of this, because it's in centimeters, and it's just so different than what we see on the Navy website. But then, if you go on down here, it explains about the model, SMOS, and it says the thickness of thin sea ice, or SIT, is daily retrieved from observations of the L-band microwave sensor SMOS, or soil moisture and ocean salinity, horizontal and vertical polarized brightness temperatures in the incidence angle range of 40 to 50 degrees are averaged. The ice thickness is then inferred from the polarization difference and the intensity using an empirical method. And here is the paragraph that explains it. Thin sea ice occurs during the freezing season. The freezing season meaning what the Antarctic is in right now, not the Arctic. In the melting season, the thickness of the sea ice is highly variable, and the emission properties in the microwave change due to the wetness of the surface and occurrence of melt ponds in the Arctic. Therefore, thickness data are calculated only during the freezing season, that is from October to April in the Arctic, and from March to September in the Antarctic. During the melting season, the procedure does not yield meaningful results. And then it goes on. So I'm going to leave a link to this page, and y'all can look at this. But so what this means is, when you see, like on Sam Carana's page, he put up a blog he put up one this week about tipping points, and here's this image, and he calls this Arctic sea ice thickness. And he says here that the image on the right from University of Bremen shows that on July 25, 2023, there was virtually no Arctic sea ice left that was more than 30 centimeters thick. So, that sounds very alarming, but when you look at it, this is the same image. It's the SMOS/SMAP version 300 of what I just read to y'all, and it says, and so this is thin ice thickness. This is from the thin ice thickness model, and so this is from microwave imagery that is not accurate, since this is in the melting season. So someone needs to tell Sam Carana that. And so it invalidates that what he shows is Arctic sea ice thickness is just totally invalid. And so I just what'd I do? I just wanted to bring that to y'all's attention, and thank you thank you to my viewer, to Dr. Lars Bergman for bringing that up. It reminded me of this page that I saw on the Bremen website, so I thought, well, I'll go back and look again, and yeah, sure enough, it that thin ice thickness model is not intended to be used during the melting period, which is what the Arctic is in right now. And so I don't even know if the University of Bremen has a model that even shows the thickness of the Arctic sea ice. I couldn't find one. I couldn't find it. It's got sea ice concentration, which we can see, and it matches up with all the other models that we have, but I couldn't find a thickness model, so I don't know. So this is why I don't use this website, because it's hard to find the data that I want. And anyway, I'm used to using the Navy website, and they've been updating this week, and I'm used to using National Snow and Ice Data Center and NASA Worldview, and so for me those work right now, and that's what I'm going to stick with. So I just wanted to start off by showing y'all that. So thank you, Lars, for the comment, and it reinforced what I had read on University of Bremen and explained it in a little bit different way to understand, why that model is just, we can't use that for melting season. So, and one more thing, down here on this thin ice thickness model, I don't know if this peach color is this right here at 30 centimeters. I thought it was up here above 50, above half a meter, but since it's only looking at the thin ice, it could be, I don't know. So until I learn more about this, I'm not going to use it. So there's that. So now let's go through Climate Reanalyzer. Well, first of all, I wanted to, before we go over that, I wanted to go over the Hilary. Right now it's a tropical storm. It's a humongous area, and it looks like another one coming up. And see this atmospheric wide band of water coming up all along the coast of Mexico and covering Baja and Southern California. It's covering almost all of Nevada now, comes up into Idaho and up into Montana and all the way over to North Dakota. And so it's a humongous system. And here on hourly forecast maps, you can track it here. This is all on Climate Reanalyzer, and this is for a couple of days. And if we refresh, we'll get the latest, I think. You can choose where you want to start. So here's the latest at 21 Zulu for today, and then you just, and it, here we've got precipitation and sea level pressure. You hit the arrow and that makes it go. And you can see the rain, see the path of it coming up. And we haven't had any rain really yet in the Reno area. I think it's going to be coming in tonight and tomorrow and into Tuesday. But see, it comes up and kind of disperses out to the west. And it shows like the yellows, that's where the heaviest rainfall is. And it's a wide band, and it's even going over into Arizona and Utah as well. There's another one that I like here. And you just hit here and it rewinds. Another one I like here is accumulated precipitation. So we get it going. And so as it's raining, it shows how much total they're getting. And this is in inches down here. The purple is 5 inches. The dark red is 6 to 8. So we got purple here. This is in the LA area. The LA area is getting slammed right now. LA and Southern California. But you can see it spreading out. So I like that one too. And then you hit the square for it to stop, and then rewind. And then another way I like to track it is on Zoom Earth. This is zoom.earth, and you can set up your filters that you want. It defaults to these weather systems. And you go to settings over here. Where's settings? Settings up here. You go to settings and you can set your time zone, animation speed, all this stuff. So I like this little program. It's free, and you can get almost it's near real-time satellite view, just within 20 or 30 minutes. And see, the latest they have here is at 6:50 p.m. today, and I have it set to Pacific time. That's my time zone. And see, it's right now 7:12 p.m. So this was 20 minutes ago where all this was. And we can zoom in, and here's where the eye, well, it's a tropical storm now, 50 miles per hour, so it's gone way down. It was a Category 4 hurricane when it was still over the ocean. It hit land right up here at 60 miles an hour, tropical storm at 11 a.m. today. That's where the eye was. Now I want to also show, where was I? See, you can go back and click on any of these times and see where it was, and when it was a category 4 was way back here on the 18th right back here. And another thing I like is the radar. This is the precipitation that's picked up on the radar, so you can see where the rain is heaviest there, and it's in the LA region right now. This is all LA and east of LA up past Bakersfield, and it's the yellow is heavy rain, and then moderate, and then like the light blue is light rain, and so on. And it's just dumping, and then it's going to move on up. It's going to go pretty much straight north and come up through California and then Nevada and east of Reno. The heaviest part, here's Reno over here, but it's a wide band. And I wanted to also show, let's turn that off. And the reason I'm kind of spending some time here on Zoom Earth is because NASA Worldview is not showing anything right now. I thought that was convenient. And so here, see the cloud and how wide it is? It's a humongous system. It goes all the way up into southern Canada. Let's see now. So it's humongous, and you don't know what's in that water too, because it's picked up out of the Pacific, and it's just dumping as it goes. So I like that. Also, you can choose all of these different things over here. Like if you want to just see radar, this is the rain. That's just the rain, and so it blocks out the clouds, and you're just seeing the precipitation, and it's showing like heavy rain, 0.32 inches an hour, tropical storm warning, and so on. And we can see precipitation here, and it's showing inches an hour again. It's just showing up a little differently. If you want to see wind, here's the wind, and it shows the currents. This kind of looks like Earth null school with the arrows with the currents. And see, this was at 1 p.m. And so let's go back to currently. 7, 8 p.m. Oh, it's forecasting now. But you can use this for forecast. And then so it shows wind speed 50 miles an hour going through Los Angeles. And then you can also see temperatures and actual temperatures. See, it's cooled down. It's in the 60s, and over here in the mountainous region of California, it's like in the 40s. And we've cooled way down. See, Reno is 61 right now. Humidity, look at this. We've got 65%. We hardly ever have humidity that high. And of course down here, 91, 89, 96. Here it is over the ocean. And so on. And then here's relative humidity. Here's dew point. Humid, 66. And here's your barometric pressure. And it's 998 millibars. So 1,000, when it's around 1,000, it's, it's not that destructive. But once it starts getting too much lower than that, you get the high winds and really destructive weather. But there's that. So I mean, this is just a neat little program, and I use it a lot. And you can also see the fires. You can turn on the fires, and we've got fires over here in Northern California, Oregon, Washington. We've got some, see, popping up, Idaho, Washington, and of course Canada fires. And you can see the smoke with all of this too. So some of this rain is going to have smoke mixed in with it, along with whatever it picked up from the water that was down here. So there's that. And if you zoom in, you can see, now there had been some fires down here in Southern California. It looks like the rain put it out, but we're still having a few. Pretty, 466 acres. That's the Coyote fire, 100% contained. Here's the Miller fire. No info on that. Plant fire, 5,000 acres, 60% contained. So, if they get dumped on, the fires will go out. But if you just get a bunch of wind with not very much rain, then it's gonna make the fires bigger, obviously. And then here's, see, the You can see the clouds going all the way over to New Mexico, and this is Arizona, so they're getting stuff too. Here's Utah. So I just wanted to kind of show how you can track things here. This is very easy to use, very easy. So with that, now we'll get on with the show. So we're looking at the 2 meter maximum temperatures for today around the world, and here in the Arctic we're still seeing a lot of greens, which is warm air, but we're getting aquas, and see dark aqua, and so that air is at freezing or just below freezing. That's air temperature. And then coming down, see it's cooler coming down from Alaska and northern Canada. This had been hot earlier this week. We still have reds in northern Canada and across. We've got reds across most of the U.S. We've got whites in the central part of the U.S. down through Texas and across. So there's a heat dome set up here. I mean, these are whites here. So that's 40 degrees C or higher, or 104 degrees Fahrenheit or higher. So some very high temperatures, and where you've got humidity with those high temperatures, you're going to be running into wet bulb problems. We've got a lot of whites over the interior of South America. Here in Africa, here's the Congo, and here's Northern Africa, and Saudi Arabia, here's Iraq, Iran, and see we've got whites coming up into Spain, France, all the way across these Middle Eastern areas and over to Pakistan and India. Here's 2 meter temperature anomaly. We've got browns here over the Taimyr Peninsula in the Arctic. We've got some tan or light brown coming across the Arctic region. Right next to it is blues, which is cooler than normal. Greenland is in browns again. They've been having rain and some snow on this west side again. And browns in northwest Canada, and then blues coming down. And see the patch of blue, and see I'm in the blue right now, so it's cooler than normal. So where this storm is coming up, it is bringing some cooler air with it, and then browns on either side. Here's the flat view, here's the Atlantic. Look at the browns from Spain all the way across into southern Russia and Kazakhstan, and then coming into China and so on. I mean, this whole area is in the browns. Australia, you've got some blues on the north end and browns on the south end. Africa, you're almost all brown. South America, you've got mainly browns and blue on the southern end, and then browns on this west side. And in the Antarctic, it's a combo plate of browns and then blues and purples. So the blues and purples are colder than normal, and then we've got red and reddish brown over the Weddell Sea here. Here's our overview worldwide. We're up 0.75 C, higher than normal. The northern hemisphere is up 1.06 C. The Arctic is up 0.87 C. Now that's come down. That had been up over 1 point something higher than normal. The Antarctic is at 1.36 C, lower than normal. Southern hemisphere is up 0.43 C. The tropics are up 0.9 C. That's gone up. And we can see the tropics are higher than worldwide and the Arctic as far as temperature anomaly, just under northern hemisphere. So that's not a good sign. And we saw precipitation in clouds. Let's look up here. Here's the rain on the west side of Greenland, along with snow coming pretty far in over the interior or the ice sheet, and then rain next to the Baffin Bay. We've got rain coming up by Iceland. We've got rain in the Barents Sea and the Kara Sea and at Russia. We've got rain at Alaska and coming across in the Bering Sea and Bering Strait. Then we've got a little bit of snow over this East Siberian Sea and over part of this Canadian archipelago. Then we saw that from Tropical Storm Hilary, and here's the flat view. And here it is. See, and I'm not sure if which way this one's going, if it's going to feed in to what we've already got here. Well, we can look on Zoom Earth and see. It's not showing. Let's go forward and see if here's the latest, 7:10 p.m. Yeah, see, those fires are really popping up now. You can see them really good. So, it's not showing what this one's doing. So, let's go back here. And we've got rain really far south, see below Africa. This is coming up to the sea ice, and then freezing rain too, right there. So, there's that. And here's the jet pieces. What used to be the jet stream is just pieces here and there, and it's just very chaotic. And see here it is with the hurricane / tropical storm coming up across the US and Canada there. So See, lots of broken. No rhyme or reason. Southern hemisphere broken up too. And sea surface temperature anomaly. This is for yesterday. And here in the Arctic, where the ice has been melted for a few days, see, it's already heating up in the browns. Like this dark brown is about 3 to 4 C higher than normal. The lighter brown is 2 C higher than normal. The bright red is about 5 C higher than normal. And then moving into pink, it's about 7 C higher than normal. And then moving into white is about 9 C higher than normal. And remember, they expanded this chart about a month ago, going up to 9 C higher than normal, and also on the other end 9 C lower than normal. We're not seeing much of that, none of that up here. So we've got reds and pinks in the Kara Sea, Barents Sea, browns. Laptev Sea is seeing reds and browns all around this Russia coastline. Here, this East Siberian Sea, this is really melted out. This is in light brown and dark brown there. Here's the Beaufort Sea. This is still collapsing, but on the coastline of Alaska and Canada, you can see red moving into pinks. Baffin Bay, we still have some blues on the west side, where the ice, the melt from the ice is flowing into the Baffin Bay. So that's colder than normal, than browns. Here, in the North Atlantic, this is our evil eye, and it's heating back up. This is just south of Greenland and just north of Newfoundland. And then off this off the east coast of the U.S., we've got the dark brown. See, the Gulf of Mexico is heating up into darker brown. We also have, with this hurricane, see, we've got warmer water now all along this whole coast of California. Before, there had been a break, and it had been cooler, but now it's back up to brown, and Baja brown. And here's our big blob in the upper northeast Pacific, off the coast of North America. Here's the flat view, and we had browns all the way through the Atlantic, some shaded brown, and this Mediterranean is going back into brown modes and dark brown. Also the Black Sea, Caspian Sea, Persian Gulf, and Red Sea, those are all going into the browns now. Indian Ocean, same thing. Here's the Pacific view, and here's this evil eye. See, we've got red right at the equator here, and the blob, it had gone down to brown last week. Now it's moving back into reds and pinks, and it's coming out from Japan there. And then this other whole big area of dark browns, we've got 2 lines now in the North Pacific. So there's that. Now we'll move to methane. And I'd like to thank the person that donated this week. Thank you very much for your very kind donation. It's very much appreciated. And if people would like to support my work, there are 2 ways. I've got a PayPal link, a PayPal me link in the description box below for if you want to do a one-time donation. Or if you'd like to join my Subscribe page for $5 a month, that's also in the description box below. And I do pretty much daily reporting over there for my members. And I do a midweek update, kind of like what I do on Sunday. But it's just for my Subscribe members, and I share all of the daily methane data over there, and other things too. So we'd love to have you over there too. So that's my little plug for today. And my YouTube channel is not monetized. I don't get any money off of the channel. In the last year or so, YouTube has started putting up ads even on non-monetized channels. I mean, I've applied a couple of times and they turned me down for monetization. And then I just said to heck with it. And I don't want ads on my videos really, but what they do, in order for them to make some money off of me, they put their own ads. And so if you don't want to see the ads, you can download the Brave browser and use Brave, and that blocks out all the ads. But so YouTube is getting some money, and I'm not getting any money though. But you know, I don't pay for the service either for YouTube, so you know, they host all of this for free. So you know, if they want to make a little money, you know, so be it. But it is what it is, and I'm not here for the money. I'm here to document the collapse, and also to talk to people about God and Jesus, and you know, how you need to get your spiritual house in order and be ready to exit the planet, and be ready, whatever that means for you. For me, it means getting right with God and Jesus. So anyway, here we are looking at the NOAA methane data. This is for yesterday, the 19th. Met-B satellite in the morning, 1,000 millibar level. The mean or average was 1,844 parts per billion. We can see the highest readings were here in Western Russia and Finland and the Scandinavian area, and a few more pinks further east over Russia. In the afternoon, the mean was 1844. On the Met-OPC satellite in the morning, the mean was 1844, and the same areas have the highest readings from Sweden, Finland, all the way across this part of Russia here. Also up here, just north of the Canadian archipelago. And in the afternoon, the mean was 1842. On the 487 millibar level, back to the Met-OP-B in the morning, the mean was 1922. It's almost all pinks. We've got just reds, which is lower than pink, right around the equatorial region. And so the pink is a range. It's 2,000 parts per billion up to whatever's the highest number here in the range. And this one is 2420 parts per billion. In the afternoon, the mean was 1924. On the Met-OP-C in the morning, the mean was 1891. And we can see a lot of pinks, pretty much covering this northern hemisphere. And in the afternoon, the mean was 1891 again. And see, the pinks are coming further south. And a little bit of pink over the Antarctic too. So here's our weekly chart, just tracking the Met-OP-C satellite for the 487 millibar level. Our average on the 19th was 1891.0 parts per billion. That's a decrease of 3.0. So we've had 2 weeks of decrease now. Last week it went down 2.5, and this week it went down 3.0. So we're back down just above this 1890 line. And here we can see what happened this week. Here we were at the show last week at 1894. So on the 13th, no change. 14th, it went up 1.0. 15th, up 1.5. 16th, down 0.5. I think I messed up. So the 15th went down 1.5. On the 16th, it went up 0.5. 17th down 2.5. That was a sharp decrease. 18th down 0.5. And 19th no change, giving us an overall decrease this week of 3.0. Now for all 4 readings together on 487 millibar, it averaged out to be 1907.0 for the 19th, giving us a decrease of 3.25 this week. So that's in range with the Met-OP-C satellite too. And then on the 1000 millibar, for the 19th, the average was 1843.5, so another decrease this week of 2.75. So I don't know why it's going down. We do see stair stepping normally in the summertime, but we're not out of the rising season, not yet. Usually not until mid to late October. I don't think I've Okay, I'll be back with the CAMS data. I don't have this prepared yet. I thought I did. I'll be back. Okay, I'm back. And now we'll look at the CAMS methane data. This is methane forecasts, and it's from the Copernicus Atmosphere Monitoring Service out of the EU. And our base time and valid time are both for Saturday, August 19th, starting with the Arctic area and surface level. So the data is for Saturday, and the forecast period is Sunday, Monday, Tuesday, Wednesday. So first off, we're seeing this area just not slowing down around CAMS NOAA. I think it's going from billowing to hemorrhaging, frankly, and why no one is reporting on this. The only reason I can think of is if this area is under Russian military control, and it could be, and then they, whatever's going on there, you know, that would be kept secret from the public unless they wanted to reveal it. And there's a hot spot, a couple of hot spots here in the North Kara Sea too. So, I mean, it's anybody's guess why this is billowing here and hemorrhaging. It could be clathrates that have thawed out. Now, it could be, my theory is that it's from nuclear waste that was dumped. Novaya Zemlya, this island here, was where Russia did a lot of nuclear weapon testing during the Cold War, and they tested bombs in the air, underground, in the water, I mean, all over. And Tsar Bomba, which is the largest nuclear bomb that's been detonated, was detonated just, I think it was just west of Novaya Zemlya, but it was in this area, and they dumped a lot of nuclear material, radioactive nuclear material, into the Kara Sea, thinking, you know, it's cold and it's icy up here, we'll just dump it there, it should be okay. So I'm thinking they might have dumped some up here in the North Kara Sea, and maybe that stuff is hot and it ate down and, you know, it's melted out or thawed out methane clathrates, and that's why it keeps billowing. That's my theory. And we do know there are, I'm not sure how many nuclear submarines that are at the bottom of the ocean. This whole area, and I know Russia was developing a program to try and clean up the Kara Sea and retrieve the nuclear waste and do something with the submarines. I don't know where they're at with that. But if you dig it up, where are you going to put it? And if you go to the trouble of digging it up, you know, if it's radioactive, which it is, you know, that's going to be putting people's lives in danger. So maybe, you know, unless they can have robots do the work, I don't see that that's that will be successful, really. I just don't see. And seriously, where are you going to put all that? So, you know, these are things we forget about. There are lots of articles out there about the nuclear waste in the Kara Sea and that whole area. And we tend to forget about it if it's not just in our face all the time. So that's why I bring it up from time to time. Okay, so from Norway over to Russia, there's a big blob. And then here in the interior of Russia, see, it's picking up. Permafrost is thawing out. And then southern Russia here on the east side is filled up. There've been fires over here, fires in other areas too. Here's Alaska. See, that's picking back up. Okay, now once the rain is done with this hurricane / tropical storm, we'll be seeing, or we should be seeing, higher methane readings wherever that was dumped. So here, Canada all the way across, we've got some big areas of methane. Here's North Dakota, that's always going. And then pretty blobby from Texas east. And see this eastern seaboard that's filled up. And the waves, see the waves moving out, yellow and yellow-green. Here's our problem spot in the North Atlantic off the coast of Newfoundland. So there's that. And then we'll go to the North Pole view. So we've got the UK filled up, Germany. I think once it kind of heats up across Europe, we'll see more methane. Here's the Persian Gulf. See, that's filled back up and spilling over the coastlines. Here's India. This is filling back in more. Here's China, filling back in. This is Korea here. And the waves moving out. And this is Mexico down into Central America. Here's South America. This northern part of South America, I mean, it's usually high, and we're still seeing it high today too. Well, that's just around the equator too. Now we'll go to the global view. And here in the southern hemisphere we're seeing this darker blue, a little bit more of that as the methane has gone down in the last couple of weeks. But in the forecast period that goes away, indicating that methane will be going back up in short order. Now this lighter blue is 1860 parts per billion, and that's the main background color in the southern hemisphere, and this blue is 1840. So there's that, and then 500 HPA, you can see the heaviest. See, here's Russia, China, Southern Asia, India, coming all the way across. Here's the Persian Gulf. And we've got heavy swirls coming around. And we've got a heavy spot just next to Australia. And then see these reds, they're coming further south. It redistributes in the different seasons. In total column, this is getting worse daily. Look at this. We've even got a high reading right up here in central Russia, but it's all the way. This is this is Russia here. Here's Japan. Then it covers most of China, all of Southern Asia, most of India, Pakistan. It's covering part of the Arabian Sea, Middle East, Saudi Arabia, and then see it's coming up and around into Africa. And here's a dark one too in the center of Africa. So this is looking worse day by day. So I don't know. There's that. And then the rest of the data from CAMS that I'd like to show. This is sulfur dioxide for today. We've got a lot of higher readings around the globe for various reasons I'm not sure of. Some of it has to do with plate movement, the tectonic plates. I'm not sure what some of the other is from. This is total column. Here it is at 500 HPA. So we've got a lot just hanging out at 500 HPA. It had been coming across Canada and the US this week. We've been seeing high readings here, just over or not far from, this is Ukraine. And I'm thinking that this is from the bombing, from the war. And I don't think any climate scientists have done a study on it. I don't know. But I think it would be a wonderful project to see how bombs, different kinds of bombs and artillery, things used in warfare, affect the atmosphere and the greenhouse gas levels. I think that would be quite interesting. I haven't seen anything like that, because it's got to affect it. I mean, it's got to. How can it not? Here's the Pacific view, and we can see all this new sulfur dioxide all the way around. Now this one is from volcanoes here in Peru. This one is from Popocatépetl, but look at all of this, and it's swooping down over the U.S. And this one's coming across Canada and up. And then here in the Pacific, I don't know. So I think it's plate movement. Here it is at 500 HPA. So this is pretty high to be hanging around at 500 HPA. So this is why I'm thinking it could be plate movement. Here's the ozone hole over the Antarctic today. You can see it's growing, and the danger zone areas are expanding. The purple inside the thick black line, the purple is 200 to 220 Dobson units. This blue color is the next level down of 175 to 200 Dobson units. Anything under 220 Dobson units is considered to be in the danger zone. And so we've got a lot of area. This is over the Weddell Sea and north of Antarctica, and over the north end, and then over the south end and the Ross Sea. And then quite thin, we've got the aquas and greens there. And then thicker further out. Here's the Arctic ozone, and we can see that it's diminishing. Wildfire smoke will make it go away. High methane readings will also make it go away. So we've got this green over Greenland and over the Arctic Basin, and then the next level down here over the Kara Sea and over a lot of Russia there. Also Canada and the US. And I consider, when you see this like chartreuse, I consider that ozone holes. When you see that and then going down into lower levels, we've got ozone holes over most of the planet. Thinning under average, below average. And you can see big wide swath coming up through the US there. Here's the wildfire smoke today around the planet. This is from the Congo region, Africa. Here's from South America, Brazil. And here's North America. Here's fires now in the US. This is Northern California, Oregon, Washington, and then Canada still. And then Russia, the main fires are over this central part today, it looks like. And here's the Arctic view. So we've got smoke coming out just next to the North Pole. And all the way across Canada. And here it is over Russia. And I just took a couple of earthquake pictures today. There were 289 worldwide. This is in the LA area. They're swarming. Of course, they're getting drenched with rain. Also, this is at Ojai, California. There are 65 clustered up here, and the largest was a 5.1 that came in at 2:41 p.m. Pacific time this afternoon at 4.8 kilometers depth. And then all of these are aftershocks. And this is just north of, in the northern Los Angeles region. And that's all of those. Okay, I'm going to take a little break, and then I'll be back with the sea ice portion of our show. Okay, I'm back, and now we'll move into the sea ice portion of the show. And we're starting with our slideshow through Climate Reanalyzer, this sea ice concentration and snow cover. I save these every day. And here we are for today. Now, we're still in the melt season in the Arctic for about another month, and it should be slowing down, but we're still going to see collapsing of areas. It just depends on what kind of weather they have up there. And so here we are today, and zoomed in, we're still seeing more collapse of this Beaufort Sea. See, more has melted on this west side. The bridge that had been coming across to Siberia is gone. Just a little wisp of ice there now. And there's a hole opening up, coming all the way across in the Laptev Sea and down, kind of next to Franz Josef Land. And here's this melting out next to Greenland. And then the rest of it's open. You can see the whole Russia coastline is open. These tributaries are almost completely opened up. And Baffin Bay is open, Hudson Bay is open. So here we were last Sunday on the 13th. So I'll just click through and you can see what happened this week. So here's Sunday, here's Monday, Tuesday, that's a big change, Wednesday, Thursday, Friday, Saturday, and here we are today. So you're seeing it being whittled down around the edges there. This is NASA Worldview today. If they don't want to show something, they just don't show it. Or for whatever reason. So, here we are. This is the U.S. Navy Arctic sea ice thickness, and we can see it's updated to today. Here's our color chart on the right, and the bright aqua is about 2 to 2.5 meters thick, and then it goes down from there. The dark blue is about 1.25 meters thick. The dark purple is about 1 meter thick. The light purple is about 0.5 meter thick. And then it goes down to nothing. If we have green, that's 3 meters thick. Yellow is about 3.75 meters thick. Red is 4 to 4.5 meters thick. And dark red is about 5 meters thick. And so we're not going to be seeing much of the things below aqua. Above aqua, sorry. So as we zoom in here, we can see Hudson Bay is open, Baffin Bay is open. These tributaries are almost completely melted out. Here's what's left of our thicker sea ice this year, and you can see it's deteriorating on this west end. Not very much bright aqua left, just a little thin line. And then we've got darker aqua on either side, and you can see it's starting to break up here just above Ellesmere Island coming out. We've got a little ribbon of green just above Greenland, and down here just above Ellesmere Island, that's 3 meters thick, and just a touch of red and yellow touch there too. So not much bright aqua left even, because we're seeing this transform to darker aqua as it's melting. Now this area at the North Pole and here in quadrant 2 of the dark blue seems to be holding. It just doesn't seem to be as deteriorating as fast as the rest of this. And then we've got, when you see any white or whitish, that's a lot of open water, and the sea ice is thin and wispy or kind of mushy, just not good ice. And so we're seeing a white area here in quadrant 4, and just not far from the North Pole, another white area appearing just north of the North Pole. And then here's what's left of the little bridge coming over to Siberia, and the white, it might as well not be there. Here's this East Siberian Sea opened. Here's the Laptev Sea, and we've got a thin layer here, and here's Severnaya Zemlya, and here's a little bit of ice left in the North Kara Sea, and here's Franz Josef Land. We still have ice around there. Here's Svalbard, and it's the ice is retreated from there. This east edge is starting to melt in a little bit now. And so let's see the 30-day animation, and this was updated to today. So the data goes back 3 weeks, and the forecast goes out to next Sunday, which will be the 27th. And like I said, we have about another month of melt before we reach minimum extent. Well, just depending on the temperatures and the weather up there as to exactly when we will reach minimum, it's hard to say. And sometimes we'll reach minimum extent, but it's still melting from underneath. So extent is only the area of the ice, and there's extent, there's volume, and there's what else? Well, there's thickness, of course, area, extent, area, and volume. And the climate scientists can't really agree on the different models. They mainly agree on the extent, and I think that's why extent is used overall. But it's misleading when they say, oh, it's so much extent, and we won't have a blue ocean event because it's above the 15% extent, 15% of the ice. What is it? 1 million square kilometers. And so it's misleading thinking that it's good ice and we won't have anything bad happen, weather-wise. But, this is just not good ice at all. It's very poor ice. So let's move in again. So I want you to focus here, just above Ellesmere Island, and this thicker ice seems to be breaking in two here, and it's like the Lincoln Sea seems to be the dividing point, and then this starts breaking down, and see on the east side it's flowing out to the Fram Strait, and on the west side it's flowing down towards the Beaufort Sea, but we can see a lot of it exiting in these tributaries. And it exits here in the nearest strait too. So, okay, here we are at the end of the model. So let's go back. Here we are today. So I'm going to click through and we can see what they're saying is going to happen this week. And immediately when we go to Monday, see it pulling away from the Greenland coastline. That's the ice drift pulling it away. The waves are moving a certain direction. The waves in the air or wind. Here's Tuesday, and you can see the darker aqua coming in here. There's Wednesday, and it's pulling away again from Greenland. Thursday, Friday, Saturday, and here we are next Sunday. So, just like this area is where the bright aqua most of the bright aqua is, just above Ellesmere. And, you know, this is still kind of hanging on. We probably will not have a blue ocean event this year, simply because they're keeping so much of this wispy ice, and you know, it can be engineered like that. Here's the Beaufort sea ice thickness. This is from the 15th, which was last Tuesday. This is the most recent data. So here's Alaska at the bottom and Canada on the right. So this is all open water, and see the white peeking through the purple there. And the 30-day animation takes us out to Tuesday for the forecast. So we can see lots of thinning down going on here. There's that. Here's the Antarctic sea ice thickness. This is from today. And here's the Ross Sea, just barely thickening into the dark blue. We've got aqua around a lot of the coastlines. And our main part of aqua is out here in the Weddell Sea, just next to the Western Peninsula. And so we've got aquas around all these coastlines. Here's the 30-day animation, again updated to today. So the forecast goes out to next Sunday. So if you'll watch right here at the Western Peninsula, in this forecast period, see it pulls away, and this is some of that thicker ice. It's aqua, but something kind of ice drift is pushing this ice away from the coastline. We've got a big hole that opens up there. So if it pushes it away, it means it's not land fast. It's not hooked onto the land anymore. Okay, here we are next Sunday. We've got a big hole that's opened up here on this Western Peninsula. So that's worrisome. And so on. And here's the Ross Sea sea ice thickness. Now this chart is different. The aqua is 1 to 1.5 meters thick. So I know it's a little confusing to go from seeing blue and purple here in the Ross Sea to seeing all this aqua. It's like, where did that come from? Well, it's a different scale. So they're kind of breaking it down a little more. And it's still open right around the coast of the Ross Ice Shelf. You can see the white down there. And the 30-day animation. And so these are valid for the 15th. And this animation goes out to the 22nd, which is Tuesday coming up. So there's that. Here's National Snow and Ice Data Center from yesterday. This is Arctic sea ice thickness. And look, they're showing this one Northwest Passage to be totally ice-free. This is the main one. It's the most direct one. For the Baffin Bay, straight out there. And what I do, any shade of blue means melting. So we're seeing melting around the North Pole. Here's the dark blue as holes are forming, and it's breaking up and it's very poor ice where you see the dark blue. And here's the extent chart. And this is for yesterday, and we kind of angled up earlier this week and kind of deviating from the 2012 curve, and then we're out a little more. So we're still well below the median, but it's a little bit more distance between 2012 and this year. Here's the Antarctic. And the brown line is the median, and so you can see a couple of areas where we're really under the brown line. And here's the refreeze chart. And, you know, remember last week it looked like it was kind of stalling out. Well, it's picked up its momentum a little more and is now angled back up. And this kind of greenish gray line is last year, and this gray line is the median. So we're still well below last year. Here's Greenland. This is for yesterday. So we can see the majority of the melting is down here on the southwest side. That's from rain and snow down there. Here's cumulative melt days for this year. And the white area is becoming smaller, meaning no melt days. And let's see, we're getting more colors now on this southern edge, denoting different amounts of melting. And here's the extent chart for the refreeze. Now we had been a little above the median for one day, and now we're back down. We're right at the median right now in August, and it's at about, it looks like 2 to 3%. We saw all of those. Okay, so I wanted to show y'all something. So here it is on the 18th. See, no problems. We're able to see everything, right? Here's the 19th. And that was when the storm was really coming up to Baja. But see, they just cut it off. It's just cut off right here, like east of Texas, and going up all the way through the Arctic and like the Pacific and all of that. That was yesterday where we started having missing data, and there are no notices, of course. And then here we are today. So you know it's not a good day when they're having a blackout day on NASA Worldview, and for whatever reason. I mean, I have theories, but I'm not going to go into them. So, here we are yesterday, looking at the Arctic sea ice. And we'll turn on the sea ice concentration layer and turn on the blue marble layer. And wherever you see green and yellow, there are holes already forming there. And see, this west side of the ice is just very, very precarious. And then here's this diagonal hole coming down. Very little white, just right here next to the North Pole, and a little up here next to Severnae Zemlya. And so the rest of the ice is in some stage of melting. Okay, so let's go back to the 12th, a week ago. And so this was Saturday a week ago. And we'll just click through when you can see the changes. Here's Sunday, Monday, that's a big change. Tuesday, Wednesday, Thursday, Friday, and Saturday. And that's all we can see there. So, I mean, I wouldn't be surprised if all this around the band here, if all of that melted. I don't know. Alright, now let's go back. Go back to our satellite view. And this is for yesterday, the 19th. And let's see what's going on. So here's Greenland. And here's the Lincoln Sea. Here's the nearest strait. Look how that's open. This ice is just tumbling through. And here's where it opens up into the Baffin Bay. And here in the interior, see, all this is melted. This is the Beaufort, not Beaufort, Ellesmere Island. And then Greenland, what have you got for yesterday? The gray ice, that's where it has been melting. And it's hard to tell if that's a cloud or a melt pond there. Just never know. Then coming on up, here's northern Greenland, and here's the east side, and here's the ice next to Greenland. And then here's this east side of the ice, and that's melting in. Here's Svalbard, clear. Here's the ice edge right there. And Franz Josef Land. And here's the ice. You can see it. Here's the hole, the diagonal hole that's opening up. Yeah, here it is. So, that's pretty remarkable to see that. And see the ice, how small it is, and lots of open water in between. Okay, let's come on up. Here's Severnae Zemlya. And wanted to show here on the 16th, I mean, this was a phenomenal view that day. This is the Vovolov ice cap, and you can see the ice just pouring into the ocean there. Right there. And you can see the different colors of the ice, so that would denote different stages of melting. So here's some, this is in the Laptev Sea. Let's move forward. And so it's hard to see much with all these clouds, isn't it? And then look at this collapse going on. This is that diagonal hole coming down. This looks awful. Look at all this open water. This is the 80 north latitude line. Look at this. This is terrible. The sea ice is just, it looks very ill. And then we can't really see the breakup yet here. I'm sure we will sooner or later. Okay, moving on around to the right. We saw the ice here coming up to Severnae Zemlya. The Kara Sea is virtually open. Lots of the Laptev Sea is open, but we can't see it because of the clouds here. See, every day it's something. So we'll just do the best we can. So here's the North Pole. And here's this melting. I mean, look at this. That's not too far from the North Pole. See, from there to there. And then coming up, and here is the Laptev Sea. Over here is the East Siberian Sea. And we've got smoke mixed in. Here's smoke coming up. Alright, so let's go over here. I'm starting to fall asleep. I'm tired. Here's the Beaufort Sea. You can see the collapse going on here. See the wispy ice. And down here is the Bering Strait. And then this Bering Sea is right here. Yeah. So, can't really see much here because of all the clouds. But suffice it to say, this East Siberian Sea has opened up. And now we'll go to the Antarctic. Here's the Western Peninsula. Here's the ice. So this is where we saw the ice drift, the ice being pushed away from the coastline. We're starting to see edges here. And here's the Avery ice shelf. Can't see much of that. Can't really see much there. See nothing there. Alright, so I mean, this is still icy, but I mean, life doesn't stop just because there's some ice. Okay, here's the Totem Glacier. And the 14th there. And here we are on the 19th. Here's some sea ice from the Weddell Sea. And then So we're looking at sea ice here, quite thin out here. Here's more sea ice. And here's the Western Peninsula, back to where we started. And sea ice concentration today. And you can see all this white area, it's already in the sunlight. So I know it looks kind of weird, but it's the way it is. So it's still regrowing. Now we'll move on to earthquakes. We have 292 worldwide. This is an uptick. Here's a 5.7 South Sandwich Islands. And then these are all fours coming across. Here's Hawaii. Let's zoom in there. And we've got 18 here. 2.9 at Pahala is the largest. Here's Andreanoff Islands, it's 4.0. Okay. I'm anxious to get to the U.S. or the lower 48. Let's see what we have. We have 147 here, so that's kind of a little bit higher than what we normally have. I'm thinking this warming, here of this 5.1 and the aftershocks, I'm thinking that's making up for everything else. Here's one on the Juan de Fuca plate. This was 2.9 across from Barview, Oregon. And so on. So this rain is getting San Diego, Los Angeles, over past the coast and wide on either side. It's where the most damaging is going to be. Also, as it moves up through California, this is going to go right over Mammoth Lakes and some really ancient dormant volcanoes. So let's see what this is doing now. Okay, we're up. It's up to 71 now. That's a lot. So some of those earlier ones have been taken off. Just this 1.9, 6 kilometers east-southeast of Ojai, California, 38. No, 1.6 kilometers deep. And then was the 5.1. And then lots of 3s, and those give way to lots of 2s. Now let's look at all magnitudes for the last 7 days. And here's this, that's the 5.1 Ojai. Oh, I clicked the wrong one. I clicked 4.5 magnitude or higher for the last 7 days. That's fine. We got 93 at this level. Here's 6.1 San Jose Village, Northern Mariana Islands. And we've got ones on the plate, so on the edges here. So that's why I'm thinking a lot of that sulfur dioxide was from these plates moving. 6.5 Sola Vanuatu on the 16th. 5.2 Nikolsky, Alaska on the 19th, and so on. More 5s down here. And if we turn on all magnitudes for the last 7 days, we've got 2,069 and a lot of movement in this Tonga area. See all of that. And we've got movement on the Juan de Fuca plate. We had 4.4 on the north end, and 3.1 and 2.9 there. And you can see where the majority of it is, mainly on the west coast of the U.S. But those are the main ones. So that's my report for tonight. And now we'll continue reading out of the book of Tobit, which is part of the Apocrypha. Tobit chapter 3. Then I, being grieved, did weep, and in my sorrow prayed, saying, O Lord, thou art just, and all thy works and all thy ways are mercy and truth, and thou judgest truly and justly forever. Remember me and look on me. Punish me not for my sins and ignorances, and the sins of my fathers who have sinned before thee. For they obeyed not thy commandments, wherefore thou hast delivered us for a spoil, and unto captivity and unto death, and for a proverb of reproach to all the nations among whom we are dispersed. And now thy judgments are many and true. Deal with me according to my sins and my fathers, because we have not kept thy commandments, neither have walked in truth before thee. Now therefore deal with me as seemeth best unto thee, and command my spirit to be taken from me, that I may be dissolved and become earth, for it is profitable for me to die rather than to live, because I have heard false reproaches, and have much sorrow. Command therefore that I may now be delivered out of this distress, and go into the everlasting place. Turn not thy face away from me. It came to pass the same day that in Ecbatane, a city of Media, Sarah, the daughter of Raguel, was also reproached by her father's maids, because that she had been married to 7 husbands, whom Asmodeus, the evil spirit, had killed before they had lain with her. Dost thou not know, said they, that thou hast strangled thine husbands? Thou hast had already 7 husbands, neither wast thou named after any of them. Wherefore dost thou beat us for them? If they be dead, go thy ways after them. Let us never see of thee either son or daughter. When she had heard these things, she was very sorrowful, so that she thought to have strangled herself, and she said, I am the only daughter of my father, and if I do this, it shall be a reproach unto him, and I shall bring his old age with sorrow unto the grave. Then she prayed toward the window and said, Blessed art thou, O Lord my God, and thine holy and glorious name is blessed and honorable forever. Let all thy works praise thee forever. And now, O Lord, I set mine eyes and my face toward thee, and say, Take me out of the earth, that I may hear no more the reproach. Thou knowest, Lord, that I am pure from all sin with men, and that I never polluted my name, nor the name of my father, in the land of my captivity. I am the only daughter of my father, neither hath he any children to be his heirs, neither any near kinsman, nor any son of his alive, to whom I may keep myself for a while, for a wife. My 7 husbands are already dead, and why should I live? But if it please not thee that I should die, command some regard to be had of me, and pity taken of me, that I hear no more reproach. So the prayers of them both were heard before the majesty of the great God. And Raphael was sent to heal them both, that is, to scale away the whiteness of Tobit's eyes, and to give Sarah, the daughter of Raguel, for a wife to Tobias, the son of Tobit, and to bind Asmodeus, the evil spirit, because she belonged to Tobias by right of inheritance. The selfsame time came Tobit home, and entered into his house, and Sarah, the daughter of Raguel, came down from her upper chamber. Tobit chapter 3. So we're seeing miracles being worked, all throughout the Old Testament, the New Testament, the Apocrypha. These are promises from God to work in our lives, and we can gain inspiration by reading about others who have really been close to God and studied the Word and everything. So I love you all, and I'm praying for you. And if you haven't given your life to Jesus Christ, I recommend you do it now. So until next time, God bless you. Go in peace, and I will talk to you soon. Goodbye.